Hello, David Snopek here from Snopek Games, and this is part 3 in my video course about using the Git version control system with a game project built using the Godot game engine. And we're going to be talking today about traveling through the history of your Git repository. So real quick review, what did we learn in the last part? We learned how to install Git for Windows. We learned how to use both the Git command line, Git bash, and the Git GUI, the graphical user interface. For the command line, we learned a bunch of commands: git init, git status, git add, git commit, git log, git diff, and we learned how to do all those same operations using the Git GUI. And we learned how to create a .gitignore file for use with a Godot game project. So what are we going to learn this time? Well, we're going to learn, we're going to discuss a little bit about whether to make big or small commits, like how big to make your commits, a little bit how to deal with commit IDs. Those were those crazy hashes from the last part that identify each commit uniquely. We're going to learn how to see the differences between two specific revisions in the history of your project, and how to actually return to a specific revision. So if you wanted to actually run the game at an earlier revision. Wiping out the changes since the last commit. So this is pretty useful if you're experimenting, just trying a bunch of things, and then say, okay, I'm done experimenting. Just wipe all of that out and go back to the way everything was at the last commit. And we are going to finally talk about how to revert a commit. So we're still doing like kind of beginner stuff, but I think for any of this to make sense, as a beginner at least, you really need to have watched the previous part. So if you haven't seen part 2, please go back and watch part 2 and then come join us here. All right, so for a short discussion about commit size and does it really even matter? So by commit size, first of all, what I mean is how often to commit and how much stuff to pack into each commit. I've seen some different strategies that different folks have. For example, some people will commit after every single little change. They change a line in a file, they commit it for everything. Other people will commit everything that they've changed at the end of the day working on that particular project. These are actually pretty common strategies. They're both bad strategies, though. Because, you know, on the one hand, like, does it really even matter how big or small the commit is? Compared to not having a version control system, like committing things at all in there is good, right? Getting it in there is good. But it does actually matter how big or small your commits are when traveling through your history and looking at your history and trying to understand it. One example of that is, let's say you put a feature into your game and then a couple days later realized like, that feature just isn't going to work. That feature's no good. So you can remove it the old way, which is, going through all of your code and, cutting out the code you don't need and changing the affected lines and all of that. But because you're using a version control system, you have another option, which is actually reverting the commit that added that feature. Now, if you're following either of these two strategies, like if you're committing after every single little change, going back to revert a feature is going to be very difficult because you're going to have like 20 commits that you need to revert, and you're going to need to find which ones to revert and in what right order, and it's a mess. Or conversely, if you're committing everything that's changed at the end of the day, you can't revert that day's whole commit because it includes other stuff beyond just the feature that you want to remove. So the ideal commit is self-contained and it's a single meaningful change. So 2 rules for that. If you can describe it in one sentence, that protects you from making a huge sprawling commit where you need to have like a whole list of changes that you made. And if all of the pieces of that change are contained within a single commit. And this is to prevent you from doing that, commit every little change, to try and make like the whole feature exist in a single commit. Now, not all commits are going to be ideal. In fact, quite a lot of them won't be. This is more of a thing to aspire to do, to try to do as much as possible. You'll get it right sometimes, you won't get it right some other times, but so long as you're trying, the history of your repository will remain clean enough that it's sane to go looking through it, to bounce around in it, to track down bugs, to be able to revert things that you need to, for that feature of reverting things to actually be useful for you. Oh, and we're not actually going to go into this today, but in the future part where we're going to talk about branching and merging, there's kind of like a middle option where, let's say you're working on a particular feature and it's really experimental and you kind of don't know how it's going to work yet. So you could make like a separate branch just for that feature and commit like crazy, which can be useful when you're trying to like work on this feature where you may want to like bounce around within the revisions of just that feature, and just make like a ton of like crazy ugly commits. And then later, when you want to merge those changes in that branch back into your main branch, into your master branch, you can tell Git to squash it, which means to take all of those crazy little tiny commits you made and combine them into a single clean commit that goes into the main repository. Because doing all those little commits actually can be useful. You can commit something you're not totally sure about and then revert it after, or like commit some of your debug code just because like you don't want it to be only on your computer, to push that up to GitLab or whatever, while still making sure that your mainline history, which is what you're going to be looking through later, remains clean. So that's something we'll talk about more later, but just to let you know that that's an option. All right, so let's get started here. I'm going to switch over to my Windows VM. We're going to be working on the same project and Git repository as we did in the previous part. And like that part, we're going to be doing everything in both the command line and the GUI, starting with the command line first. And if you want to know why we're doing things both in the command line and the GUI, please go check out the previous part where I have a little explanation about that. So all right, to get started, this is the Godot project, and I'm going to right-click in the window and go down to Git bash here. That opens up the command line window. And the first thing we are going to talk about is looking at the differences between commits. So git log to show me all of the commits that exist in this repository. There are 3 of them. They start with this commit and then the commit ID here, some metadata, the commit message. You see there's the initial commit where we added that speed variable and where we added a background for our little sprite to move around on. So to see the differences between 2 commits, like to say, let's say I want to see the differences between this added speed and added background commit, I would do git space diff space, and then I can copy this commit ID, put 2 dots, 2 periods, and then copy and paste this commit ID and hit enter. And this will give me the differences like we saw in the previous part with the plus for the lines added and the minus for the lines removed of the changes that were made in this commit. And you can move up and down through this list of changes with the page up and page down keys. So that is how you see the differences on the command line between 2 arbitrary revisions. We could do any of them in here. We could do not just these 2 sequential ones, but we could do from the oldest commit, the initial commit, all the way up until the newest, and show us the differences this way. However, you will notice that these commit IDs are long and weird. So I'm going to teach you a little trick. You don't have to use the full commit ID. You can use any part of the front of the commit ID, 4 characters or longer, so long as it is unique. So if I say, like, let's say I take the first, I'll start with this one. I'll take the first 7 characters to git diff, the first 7 characters, ... and then we'll do the first 7 characters of this one. And it gives me that same first diff that we did. And the way that this works is so long as the chunk of the commit ID that you take is unique, there are no other commits in this whole repository that start with these same 7 characters, then Git will be like, okay, that's just an abbreviation for this commit, and it's cool. If there are duplicates, if there's another commit somewhere in the repository that starts with this same 7 characters, you're going to have to give a longer part of the commit ID. Git will complain otherwise. There's sort of like a informal standard of people using the first 7 characters. There's a lot of tools that always give the first 7 characters, and tutorials and stuff, they'll use the first 7 characters. There's no reason that you have to use 7. In practice, when I'm actually doing stuff in Git, I just grab a bunch. I just grab a bunch of those characters, ... Okay, I'll grab a bunch of these. Too many. Grab a bunch of these characters, and it's fine. It's probably unique if you grab just a bunch, and you don't need to sit there and count out specifically 7 like I was doing earlier. Another quick trick that I want to show you is when we did this diff from this revision to this revision, it's actually saying we're going to start from where this revision was to where this next revision took it, which means that is only the changes contained within this single commit, that diff we just did. There's another way to do that where you don't have to give a range to get just the changes for a single commit. So like, let's say we have this commit ID, and we don't feel like looking up what the previous commit ID was. We can do git diff, the commit ID that we know, ~1, ... and then that commit ID again. And this will give us that same set of changes for adding the background. And the way that works is that the ~1 says the commit 1 before this through to the commit itself. So that's a quick way to just get the changes for a particular commit ID if you only have that commit ID and don't feel like looking up in the history what is the one that came before it. You can change the 1 to like arbitrary numbers too. Like we could say 2 before this one, and that'll actually get us the last 2 commits through to now. And it's, well, not to now, to this specific endpoint. Another trick is if you want to say, here, let me just grab a new commit ID. If I want to say all of the changes since this commit ID, I can do git space diff, this commit ID ... with nothing after it. And that gives all of the changes up until now, up until wherever you are in the working tree currently. So that's another way to kind of get that same diff by approaching it in a different way. All right, so now that we've looked at the differences between commits, what if we wanted to actually switch our code to match one of those commits so we could actually run the game at that commit? So let's bounce back to this commit before we added the background so that we can actually see the game without the background. So I will do git checkout. This is a new command, checkout, all one word, and then the commit ID. And it will give a whole bunch of notes here telling you that you're in a detached head state. What that means is we're on a commit which isn't the head of a branch. It isn't the latest commit in a branch. And it gives a bunch of other like ideas of things you might want to do at this point, but let's not worry about that for now. The only thing that we're looking to see is that we have in fact gone backwards in history. So we do git log. We now only see these 2 commits. That later commit is still there. It's still on the master branch. We've just changed our working directory to be at this commit currently. So we haven't lost anything. We've just changed all of the files in here to match this previous state. And if we look in our files here, we no longer see the background PNG file that was here. We could run the game and actually show that it has no background, but I don't want to waste too much time. I always have too many things to say in these videos and they end up being super long. So we're just going to look at the files and confirm that the background.png is not there. So now that we've gone to this older commit, how do we return to the present? So to switch to the head of the master branch, to the latest commit that we have for the master branch, we do git checkout again, and then type master. And that takes us back to the head of the master branch. So we type git log. We now see all 3 commits are there. And if we go look at the files, we can see our background, JPG, I'm sorry, I thought it was a PNG earlier, but it is a background.jpg file is now there. So what if you're doing a bunch of experiments in your game, and then try them, say, okay, that was interesting, but not something I want to keep, and say I want to wipe out all those changes. Let's cover a command to do that. So let's simulate it first. I'm going to edit the main.gd with Notepad++. I'm going to add, I don't know, some kind of change. I mean, like, let's up the speed. We'll make the thing way faster. 400. This is actually a thing I really experiment with quite commonly. I'll go in and like tweak a bunch of the sort of like numbers of speed and acceleration and that kind of stuff, and then want to wipe it out because it didn't really turn out to be any better than what I already had. So anyway, I've changed the speed from 200 to 400. I've saved the file. If we go in here, we can do git diff, and we can see the differences from what was committed. The 200 has become a 400. And now we're going to decide, I don't really want that. So the command we're going to do is git space checkout space dash dash space dot. I know that seems weird, a lot of meaningless symbols. Don't worry about it. There is a sort of command line logic to it, but we're not going to dig that deep. Just know that that's what this command does. I hit enter and then do git diff again. There are now no differences. There's no output there. I come back here. It says the file's been modified by another program. Do you want to reload it? Yes, I do. And it has switched the speed back to 200. So that is a very useful little command. Speaking at a high level, the new command we've been talking about, git checkout, what it does is it changes the contents of your working directory to match some state from the repository. So it's checking out some previous revision or a different branch or whatever from the repository and making the files in your project directory match that. I hope that makes sense. So the last thing we're going to be talking about on the command line is reverting a commit. So let's say we were doing that same experiment. I already have Notepad++ open. All right, so let me go over here and change this 200 to 400. But instead of just having it in the working directory and then wiping out those changes, let's say I actually commit it. So I'm going to do git commit. We'll do -a, what we learned in the previous episode. And I'm going to say increase speed to 400. Save and close U. And it will make that commit. We can go look in git log and see we now have this new commit, increase speed to 400. Now let's say after we have committed it, we've decided that that is a bad idea and we would like to revert it. So to do that, let me just grab a piece of this commit ID first. We do git space revert space and the commit ID that we would like to revert. And so that opens up Notepad++, again in this kind of mode where you're writing a commit message. And it pre-writes the commit message for us, revert, and then this is the commit message of the original commit that we're reverting, and then this reverts commit. This is just sort of a standard message. You don't have to keep that. You could completely wipe that out and replace it with your own message. You could add your own message before or after it, whatever. In this case, we're just going to keep it. We'll save that, close it. All right. And if we go look at git log, you'll see that here is the commit where we increase the speed to 400, and here is the subsequent commit where we reverted it. So git revert just makes a new commit that is like the opposite of the commit that you're reverting. Like for all the lines that were removed here and added here, or that doesn't even make sense, but for all the lines that were removed and added, it's basically removing the added lines and adding the removed lines. It's just doing it all backwards. There is actually a way, there's actually a couple of ways in Git to actually rewrite history to make it so that other commit like didn't even exist as far as the history is concerned. I would say don't do that 99.9% of the time. There are some cases where it is useful. For example, if you accidentally committed your password to something or an API key for a third-party service your game uses, or like you were using placeholder assets from something you don't have to copyright to, like you're using the assets from Zelda or something in your prototype for your game and accidentally committed them. Oh no, I can't push that. So in those kind of cases, it does make sense to rewrite history, but it's dangerous. You can break things, like totally mess up your repo. It's complicated and hard to do, and it hides real history that your repo had that maybe will be useful to you in the future. So for the most part, don't do that. Instead of rewriting history, use git revert, which does those sort of inverted commits to add back the changes that were made. And for the most part, you will be happy. All right. So I'm going to pause the video for a moment so that I can undo all of the things we just did, and then we will redo all of this using the Git GUI. All right, so here's our project folder again. I'm going to right-click in here and go down to Git GUI here to open the Git GUI. And the first thing that we are going to do is looking at differences. So to do that, you go to Repository, Visualize Master's History. This opens up Git K, which in my mind I call Git TK, which I might accidentally say out loud, but it's just Git followed by the letter K, which we used a little bit in the last part, and allows you to explore through your Git repository's history and do a little bit of like changing operations, but not everything. So to see the differences between two arbitrary commits in Git K, you will right-click on the first commit that you want to deal with and go down to Mark this commit. And then you click on another commit that you want to see the differences with, right-click on it, and go diff this to marked commit. So this is checking for the differences from added speed commit to the added background commit. And then down here you see that same diff that we brought up in the command line a whole bunch of times. And you could do this for any arbitrary commit. I can go down to the initial commit and do the same diff this to marked commit, and then it does from this initial commit all the way up to added background, same as we did on the command line. And as necessary, because it will become necessary in a little bit, if you need to get the commit ID for a particular commit, you click on it, and then over here where it says SHA-1 ID, this is the commit ID. I think it's a little confusing that they wrote SHA-1 ID because like it is a SHA-1 hash. That's what that value is, but it's not very good user experience because like a person using it's like, that's a commit ID. What the heck is SHA-1? Anyway, that is the commit ID. So next we're going to do traveling through history, actually switching back to an older commit, which is not something that you can do in Git K. There is something that will possibly confuse you and distract you. If you right-click on an older commit, there is an option on here, reset master branch to here. Reset is not the same as checking out that commit. It will have the same net effect at first, because if we did this, it would, depending on whether you chose, soft mixed or hard here, it would actually change the contents of your working directory to match this older commit, but it's doing something more than that. It's actually changing the head of the master branch, meaning the last commit on the master branch, to an earlier commit. It's rewriting history. It's not the most destructive way to rewrite history. It is actually possible to restore from this, but don't do it. Do not be distracted by the reset master branch to here, because that is one of the evil history rewriting things that you shouldn't do. So the right way to check out an old commit is to copy the commit ID, switch back to the main window for Git GUI, go to branch, checkout, and then up here you can click this box revision expression and then paste in the commit ID. We click checkout. Yep. This is the same kind of message we saw before when we did it from the command line. You are no longer on a local branch. We are in detached head mode. We're going to click OK. And if we go look at our files here, you'll notice that the background JPG has again disappeared because we have checked out this older commit that doesn't have it. And to return to the master branch, to the head of the master branch, we do it the same way. We go branch checkout, and then down here there's this local branch checkbox, which has master as an option. And if you had more branches, they would list all the branches here. We click checkout, and now the background.jpg has returned because we are now again back on the latest commit in the master branch. So the trick about wiping out your changes since the last commit, let's demo that in the same way we did last time. I'm going to use Notepad++ to edit my main.gd. I'm going to change this to 400, save it. If we go over here and hit rescan, you'll see now it's showing that there are some unstaged changes in main.gd. This same, remove the 200, add the 400. And then to just wipe out those changes, we go to commit and revert changes, which again is not a UI decision that I would personally make if I were creating the Git GUI, because revert has a very specific meaning in Git, which this actually isn't. We are not reverting a commit like we did with git revert. We're just wiping out the changes in the working directory so that the working directory matches the latest commit. So let's click that. It asks us to confirm revert changes in file main.gd. Any unstaged changes will be permanently lost by this revert. So revert changes. And if we switch back to Notepad++, it'll say, yeah, another program has changed it. Do you want to reload? Yes, and it has gone back to that 200 that it originally was in the last commit. And the final thing, reverting a commit for real. Let's first create the commit. Say change this to 400. Come back in here, rescan. We are going to stage the changes. We're going to type a commit message. We'll say increase speed to 400. We're going to commit. And I think, do we actually have to close git.tk? I never leave it open this long. Reload. There we go. So now we can see in git.tk that there's a new commit on here, increase speed to 400. And we can actually revert the commit right from inside here in git.k by right-clicking on the commit that we want to revert and go down to revert this commit. And that has created this new revert. It didn't give us an opportunity to enter a message. It just put it in with the default messages, which have, revert, increase speed, and the commit it reverts. But there we go. We reverted that commit with full history intact. So that is all that I wanted to show you today. Please let me know if you have any questions. Put something in the comments below or send me a message, whatever. Did I miss anything? Is anything unclear? Is there anything in particular you want in future episodes? And in the next part, we're going to talk about pushing your repository to gitlab.com, which tees us up for the part after that, where we're going to talk about using GitLab CI to automatically build your project, create, exports for whatever platforms you want automatically each time you push a commit. So thanks for watching. Talk to you later. Bye-bye.